Welcome back, engineering students, to this new set of videos about the mill. It's a very versatile machine, so you're going to find it extremely useful to learn how to use it. But before we get into it, we have to review a few things about safety, then look at the various controls on the machine. And we'll break them down this way. First, the speed and direction controls, then the Quill controls, followed by knee controls, saddle controls, table controls, and the machine controller itself. So let's begin with safety. Well, welcome to the mill setup and safety videos that we're going to be doing. We're not at the Applied Technology today, but we're back in the engineering prototyping lab on the Brighton campus. Here with me is Master Toolmaker Don Howard. He's going to take us through this machine. But I just want to remind you of a few things about safety that still apply. Obviously, you see I have the safety glasses on, and we're both wearing short sleeve shirts so that nothing can get caught. We're not wearing any jewelry, don't have any long hair. If you have those things, you have to tie back. And one last thing is we're going to be using some sharp cutting tools such as this one, which is an end mill, so we're not going to want to touch any of those cutting surfaces, so we're going to get back to that. Let's just take a look at the safety procedures around a mill in the shop. You know, you might get tired of these, but one slip up on your part could mean a permanent lifelong injury. So remember, safety glasses are required at all times to be worn properly. You only get two sets of eyes, or one set of eyes actually, for your whole life, so you have to take care of them. Make sure you wear short sleeves. If long sleeves are present of what you've worn, you need to roll them up past the elbow. No jewelry, especially necklaces, rings, bracelets. You don't want anything that's going to get caught and pull you into the machine. If you have long hair, you need to tie it back or put it in a net or under a hat. And remember, there's going to be some extremely sharp tools that we're going to be using, and we're going to show you how to properly handle those. You're never to touch any of those sharp surfaces, and you're to be aware of where they are at all times. Let's take a look at the speed and direction controls. So Don, now's your time to shine. You ready to go?
Sure. Do you got a cloth so I can shine?
All right. Don, we're going to kind of start and go from head to toe, and actually there is something called the head here of the machine. Could you point out where the head is?
This is the head of the machine. It's basically the heart. It supplies the power for the spindle. And so if we start up on the very top of the head, you have the motor. And you energize that, and it will rotate, which is your spindle. All right.
So this is different than the lathe. With the lathe, the part was what was spinning, and the tool was stationary. Now we're going to have the tool is going to spin, and the part is stationary. So the cylindrical thing on the top is the motor.
This is your motor.
Okay, that's the motor.
And it has a series of drive belts that go. Has a drive belt that goes through the head, and it's connected to like a VCT, right?
CVT, constant velocity transmission.
You can take that out, right?
All right, so Don's saying that we have a CVT that has there's a belt. Is essentially this is a belt drive system.
That is correct.
All right, so with the lathe, it was a gear drive system.
Correct.
Right, that's right. All right, now with this belt drive system, Don has told me previously that you only want to be changing the speed, which is this lever,
Right.
while the machine is actually running, while it's spinning. Okay. What would happen if you did it and it's not spinning?
All right, what's going on in here is you have a cable or a chain to drive that goes up and opens and closes these pulleys. And what will happen is you'll either open this pulley or you'll give slack to that chain, and your speed won't change until this motor comes on. So all of a sudden you'll either get a burning, your belts will burn, or you'll get a big slap when the pulleys slap together when you fire this up, which basically it starts to destroy our belts. We don't want that.
So when your instructor hears the slapping or if smells the burning of the belt, they're going to come over with a red face and be yelling at you.
That is correct.
Okay. So don't touch this unless the machine is on. All right, Don. So this is the speed control. We're not going to touch it yet. Is there an on-off button on this machine?
On this machine we have an on-off button. Pay attention to 1 or 2. It doesn't mean high or low. It means forward, reverse. It could be high or low. try not to get focused on this because you can go from one machine to another and it could mean the very opposite depending on how an electrician's wired it. All right?
Well, essentially, does that change the direction that the spindle is it called a spindle?
Yes, it's called your spindle, and it'll change the direction in which your spindle is rotating. So you need to pay close attention to when you turn your spindle on, what direction it is rotating.
Okay. So that 0 means off.
Right. 0 is off, 1 means on, 2 means on. Depending on whether you're in high and low range, which is a good lead into the lever on the side of your head.
All right. So you got a lever on the side. So Jason, if you can come in over to here, move over here. That's the high-low range. Don, what is it in now? I can't even tell.
It is in low range right now. If you can grab a hold of your spindle, you can barely turn it. I have 3 positions. I have low range. I have a neutral position, and you can see the spindle can spin freely. I have a high range where it's just virtually that. It goes up into a higher range of gears and moves more freely.
All right, so just to kind of review, if I do I have to pull it in a certain way? I have to push the handle. So if I go, I don't know what I'm.
Neutral.
This is neutral. How do I?
Go way back and let it release the handle.
Release the handle.
Yeah.
That's low. Low means hard to turn this. I can barely turn that, Don.
It's in low range. Yep. Low range speeds. When we look at the front of the machine, you have 2 different speed selections, right? You have a low range and you have high range. And this lever gives you that opportunity to pick either one of those high or low range.
All righty, so I push in, I'm in neutral, I push in, I'm in high.
You want to make sure when you do that, you want to make sure you get transmission of power through the spindle. If you do not, you're going to end up having grinding of the gears, which everyone in the shop will know that you have made a mistake.
So this is kind of like the lathe before. When we change the gears, we always check to make sure that there was some engagement of the gears. Same thing here. We want to see that there is some resistance. If there's absolutely no resistance, we're not engaged.
That is correct.
If we turn the machine on in neutral, Don, are we in trouble?
As long as it don't jump out of gear, but yes, it potentially has the danger of the machine jumping into gear, which would cause it to grind gears as well.
Which just brings up a question. Why have this neutral gear at all?
We have that neutral gear so that way if we have to do any inspection or pick up our part using an indicator for indicating purposes or various operations where you don't want power going down to your spindle so you can manually do something.
I guess that makes sense. On my car, I have an automatic transmission. I have a neutral. I don't really ever use it. But if I wanted to just push my car, I could put it into neutral.
Right. Okay. Absolutely.
All right, Don. So I see kind of the speed controls, the high, low, the counterclockwise, clockwise, whatever. We're not sure which way is which yet. Anything else? Is there a brake up here?
All right. Yes. To the left of the machine on the head, you will see that I have a lever I'm pulling on. This is your spindle brake. I pull down on that. After you turn your spindle off, let me give you an example. I can't turn it on.
Okay. We're going to show that in a future video. But so you only want to use the brake when the power is off.
Correct. And that's to stop my spindle.
If you try to stop your spindle while it's on with the brake, it's going to fight it, and it's not going to be a good thing. It's probably going to make the belts smoke.
That's correct. Yeah.
Okay. All right, I'm coming up with things that probably Don has never even thought of because they're so stupid. We have to review all that information that Don threw at us about the speed and direction controls. So here you see a still photograph of the front of the head at the very top. And you see that on the very top, the cylindrical item is the motor. And on the left side is an on-off. But it has an off and the position 0 as you see here. But it also has a 1 and a 2. Depending on how the machine was wired, and this depends on the machine, 1 could be clockwise or 2 could be clockwise. But for any given machine, the direction that the spindle will spin in 1 is always going to be opposite that of 2. And we'll show in a future video how to quickly test or jog your spindle on and see how that works. The speed controller on the right will change the rotational speed, the RPMs of your spindle. Remember what Don said, this is not to be changed unless the spindle is spinning. Otherwise, you could burn or damage the belts. Finally, there's a brake on the left side. If once you turn your power off, the spindle is going to continue to spin. If you'd like it to come to a more rapid stop, you pull this brake lever down and it will cease the rotation. You're not to use the brake while the spindle is engaged under power, otherwise you could damage the belts. The speed indicator is shown in the very front, and it has two sides to it, either a low or a high, and there's a little number that will appear and you can't see it here too well, but the side that you're going to use is dependent on whether you have the machine in the high or the low range, and that shift lever is on the right side of the machine, and you're going to see that in the next slide. So here on the right side, the high, neutral, and low speed selector. So right now it's, I believe it's in the low range, and if you push that knob in and bring it to the forward position, be in the high range. If you have it in the middle, that's neutral. Don said that the neutral is only used when the spindle is not under power. You don't want to put a machine into neutral while it's moving. The high or low speed indicator, as I mentioned in the previous slide, is on the top right. So depending on where that black handle on the right is, will determine which of those two scales you're going to read. We're going to look at the Quill Controls next. Okay, Don, what else up here on the head do I need to know about?
All right. As you can see, there's a lot more controls on the head of the machine that we can see. One is we have, we talked about the variable speed. We look up here in our speed selection. In either one of these, you can see how fast your spindle's running. And we move down on the head. You've got this. This is an engage, disengage lever for power feed for Z, which engineering students won't necessarily need, but I'm letting you know what it is.
How do I know it's not engaged right now?
Here there's a chart that says it's disengaged or engaged, and the lever is swung to the disengage.
You're making an assumption that one, people know how to read, and two, that they actually will read. But anyway, now, yeah, I see that. All right, so disengage, engineering students, there's probably not many occasions you're ever going to use that. You'd have to ask your instructor before ever engaging that. Because this Z, which is this quill, would drive something down into your part. It could drive into the what's this called, a vise? Sorry, I should know that. Now this vise probably costs upwards of $500-600.
$600-700, depending on the size. This one will be right around between the $600 to $700 bracket.
So if you drill a nice hole into there, no one's going to be very happy with you on that day. All right, so we're not going to generally use this button. All right, what else up here, Don, should we know?
All right, this is our spindle is housed inside a quill. In order to get our quill to move up and down, or move your spindle up and down, if you wanted to drill holes or reposition, you would grab a hold of this quill handle, and this is your rapid quill handle, your rapid quill feed, so you can move the quill up and down.
Would this be used more in drilling operations, Don?
Yes, or rough positioning.
All right, so we've got this. So this, what's the quill again? This is the quill.
This is a quill.
This big thick thing is the quill.
Right,
and okay.
This is your quill, and it doesn't rotate, and this is your spindle, which rotates inside your quill, and it enables your quill, your spindle to move up and down. All right.
All right.
Quill stop. All right. This locks your quill so it don't move downward. All right. This is our quill lock, and then we have a quill stop. Can you get in?
Come on over to the right, Jason, and come on in. All right, Jason's moving the camera vantage point so you can see it better. So there is a quill stop.
Right. This quill stop is used, say you were drilling holes to a certain depth, or you were milling pockets to a certain depth. You can move this up. It's on a threaded, so you can get a fine adjust. Or there's this little push button right here on this specific model. You can push this button in. I'm trying to see it. There it is. push this button in and you can get a rapid up and down. All right, so you can adjust your quill stop, and then you bring your quill down to rest upon it, and then you would lock it with your quill lock. All right.
Would you say that the quill lock is used pretty commonly in operations?
The quill lock is used quite frequently.
Because when we're machining something at a given height, we don't want it to be able to move.
That is correct. You don't want it to drift.
I want it to drift. All right, Donnie. Okay, so I see some other things up here. Anything we need to note about? What about this wheel? What's that do?
This is your fine quill traverse handle right here. If I engage my feed rate lever, I gotta get it down here. If I engage my feed rate lever, I can gradually move my quill down by turning this handle. All right. Some machines are equipped with this. Some machines, it's an attachment, so you can take it right off, and it may be hid away somewhere. So it's not something that we use frequently.
Can you demonstrate that again, so I can catch?
All right. As I rotate the handle, I can get a fine feed with this, or I can get a rapid feed. All right. There, I just hit my quill stop, and it released and went back up. So I would engage here, and then I can rotate this, and I can get a fine feed. All right.
So, Don, that's probably a less common control that students in engineering would do.
That is correct.
Most of the time it would be disengaged where it is now, so this wheel would do nothing.
Right. The wheel is unfunctional.
Okay, so it's disengaged. All right. I see a knob over here. Okay. All right. Okay, wait, Don, let's let the camera move. We've got a cord coming. Nice job, Jason. All right. I've never seen anyone move that handle before, but then again, I haven't seen a lot of things.
All right. On this side of the machine, we have our feed selection, just like on the lathe. This is feeds per rev, or it advances how many thousandths per revolution the spindle turns. All right. So you have three different selections: 6 thousandths, 1.5, and 3 thousandths. Per rev. So what will happen is the spindle rotates one complete revolution and will advance that amount. And that will only work when you have your spindle feed engaged, which is your Z feed.
All right. Now, once again, folks, let's just remind what Don said earlier. We're usually disengaged on the power feed on the quill, which is the Z axis. Is that correct?
Yes.
This is negative Z is down?
Negative Z is down.
Positive Z is up, and we're going to see that later on. So most of the time, we're not going to be fussing with this. In fact, there's probably very few times when an engineering student is going to use a power Z feed.
That is correct.
There's several knobs here on the quill, some of which we will use somewhat often, and others that will be used virtually never. But it's good to know what they all are. The most important one is the quill feed handle. This will cause the spindle to move up and down. Actually, it's going to cause the quill to move up and down, which will in turn cause the spindle to move with it. The quill lock, if you turn that and lock it, that'll prevent the spindle and quill from moving up and down. The spindle, of course, is at the bottom. That's where we're going to put tooling into. The quill stop there, that cylindrical thing, can be moved up and down, and that's used probably most often when someone wants to move the quill to a specified location, perhaps for drilling or for milling out a pocket. The fine quill feed lever, there is a lever under it where you have to engage that, and by doing that, the fine quill feed could be used manually to move the spindle and the quill up or down instead of the quill feed handle. So that's what's happening up here on the quill, except there was this one other thing, the power Z, which is always going to be disengaged for engineering students. Not shown, but on the left side of the machine are different power Z feed rates, and you're not going to use that knob either. So just keep this power Z disengaged and everybody's going to be happy. Next up, the knee of the machine and how you move that up and down.
All right. And those ways support your knee. All right. Your knee is connected to it, which is another part of the mill. And the knee is driven up and down with a vertical lead screw. And that vertical lead screw is controlled by using this vertical hand.
All right, Jason's going to move over to the other side. All right, we're in a little tight quarters here. All right, Donnie, let's just, so this protrusion out here, this is known as the knee.
That is correct.
So that's this type of mill is sometimes called a knee mill.
Yep, a knee mill or vertical mill. Yep, vertical knee mill.
All right, so we're on the knee now, and there's this crank. Now, Don, a lot of times I see it this way. I mean, why is it on there like that?
Safe storage. If I have this thing sticking out, someone walks by with a cart, or it happens to walk by themselves, they can either injure themselves, or a lot of times we see these handles getting broke off because of poor storage, they get hit and busted. So this is safe storage. And if you're machining a part, and there's nothing more annoying than having this out like this, someone walking by, hitting it, and now your reading's off and you're milling and you don't even know. So it's for your own safety and for your own part precision.
All right, so that's how we should normally store it unless we are adjusting this knee. So can you put it back the way it is if you have to adjust it, and talk to us about what turning this knob does?
All right, turning this knob allows you to raise and lower your knee in a vertical motion. All right, the graduations on this vernier scale are within 1/1000ths increments, so each division is equal to 1/1000th. So one complete revolution turns it 100,000ths, which is 0.1. So each individual division is 0.001.
Wow, okay, that's pretty good. So this is moving this whole unit upward?
Yes, that is correct. So as I move it upward and I say, oh, I went too far and I want to back it down, I just don't back it down to the number I want. I back it past and I raise it back up to the number that I desire. And that allows me to take out backlash.
All right, so backlash is the play there is in a screw. So you're always going to want to get to a height by turning in one direction. Correct. Don't turn to bring yourself down. Always bring yourself down further and then come back up. All right, these are things that might not make a giant difference for an engineering student, but for a machinist, where thousandths of an inch mean the difference between you keeping a job or getting fired, it's a big deal, isn't it?
That is correct. Very correct.
All righty. So this moves our knee up and down. Now, Don, there's some other things here on the left that Jason might need to get down to.
All right. As you can see, we have an oiler here. It has a lever on it. We're going to pull that. Basic maintenance is daily maintenance, as you would pull that lever once a day. All right, when you go to use your machine.
So generally once a day means you come up to your machine, you should pump the oiler one time before you get started.
Yes.
All right, where's that oil go? Does it just go down onto the bottom of the base? Because I see oil down there.
It runs throughout the machine. There's a bunch of oil tubes, and they're drilled and designed to go up, and they oil all the lead screws. They oil the ways of the machine.
So this isn't like the engine of a car where there's an oil pump pumping oil all around?
It's similar, but it doesn't do it continually. It just runs out there and floods the areas, and it just drips out, and that's why you see the oil in the bases.
All right, so the oiler is an important thing. Don, there's a bunch of these silver handles all around. Can you tell us what those are? And Jason, I don't know if you can see them from that angle.
All right. These silver handles here, these will be your knee locks, all right? If I crank up my knee and I wanted to stay in this one specific spot, I can crank these down, all right, and my knee won't move, all right? It becomes very difficult to move. It helps hold rigidity, all right? We don't recommend that you lock these down, all right? We like to see you students leave them loose because what happens is it causes a binding, and sometimes you don't realize you need to take out backlash. It causes excessive wear if you don't release them when you go to crank your handles, all right?
I think the other thing is there's a lot of mass and rigidity in the knee already, so locking it down is not adding too much to that.
Not at this point, and they're fairly new machines.
There aren't too many controls on the knee, but they are really important. The one on the right here, the knee height adjuster, right now you see the knob in its storage position so people do not run into it. So anytime that you are not actively changing the height of the knee, you would want to put the handle in this position. When you want to actually change the height, you would take this off and turn it around so that these teeth that I'm pointing with my cursor are going to engage with the teeth over here on the other side. Now, one rotation of this handle will move the knee 1/100,000th of an inch. Now that means 0.100 inches. In addition, on the right side, you have these knee locks, which if you lock those down will prevent the knee from moving. And Don recommended that those stay loose because a lot of times they can be forgotten that they're locked, and then someone will crank the knee height adjuster and you'll get extra wear on the machine. Finally, on the right side, there's the oiler, and I'm pointing with the red arrow right to the handle. The first thing you should do when you go up to a mill is to pull this handle down, and that will pump oil through the ways and all the lead screws and so forth. So all the parts that need low friction and we want to keep in good working order, that oil gets to them. So this has been the knee. Let's move on over to the saddle.
All right, so those two back buttons. Now I see something here, but we're probably going to talk about that later, or can we do it now, Don?
We can talk about it now. It's attached to what we call a saddle. All right, and the saddle moves on the knee front to back, which is considered your cross feed or your y-axis.
All right. So let's come on over here, Don, so Jason can get into this. So this green right here that's underneath the silver, this is known as the saddle, and the saddle moves in and out, and in is what axis direction?
That is a y-axis direction, and it is
positive going in.
That would be, if the table's moving in, you're actually moving your spindle in a negative direction.
All right, Don. Yeah. So we'll get over that later on. Generally, the positive y direction is in. Right. Okay. But if you move the bed in, your spindle is moving like it's the part relative to the part. It seems to be moving out because this is actually stationary, except that it's rotating.
Right.
All right, folks, you're going to have to think with both left and right sides of your brains, which I'm having trouble with now. All right, but anyway, the saddle gets moved in and out with this crank that Don is turning right now. Now, this has graduations on it also, Don, but it seems like they go from 0 to 200.
Right. This one complete revolution on this vernier scale is 200 thousandths, and each division is 1 thousandths.
All right. Now, is this the lock to lock it from going in and out?
This is the lock to lock the saddle from going in and out, yes. We don't like you to lock that either.
Don't lock that one. So basically, don't go messing with any of those locks on the left side.
That's right.
Okay, I got it. Oh, no, don't use those either?
No.
Okay. All right. These ones on the front will lock the table from going left to right, but Don says don't use those either. All right. Okay. Anything else we need to know about the saddle, Don, before we move to the table?
No.
Okay. The saddle controls, there's only a couple of them that we have to be aware of. The first is the round wheel there, which has a handle that'll snap out, and that's our cross feed or y-axis adjuster, and that will move the saddle, which is this green item that's below the table. That'll move that toward or away from the operator who's at the cross feed adjuster. So that's known as our cross feed. The other thing that Don talked about is there's also a saddle lock, but as with the knee locks, he said don't engage those either. Our last item that's going to be moving on is the table, and let's see what Don has to say about that.
Down to the table.
This is your table.
All right.
This
is a table. Okay.
And that gives
Well, okay, I didn't. So Don, this is the table.
this is your table. All right, it's your precision ground surface, so we don't want to mar it up or ding it up, drop stuff on it. You want to treat this very well. We're attaching things to it, so you don't want to damage it. That table moves in your X direction, longitudinal, across on your saddle.
All right, so this moves, and I'm just here by this thing here, and it's kind of fun cranking, and you got to do all the cranking, so it's my turn. This one also goes 0 to 200, so Don, I'm presuming that this is 200 thousandths on one full turn, which is 0.2 inches. Am I right?
That's correct.
But the graduations are every thousandth of an inch, which you would call?
Yes, 1/1000th of an inch.
Thousandths. Okay. All right. And also on the handle, it tells you that. So maybe, Jason, you can come up here and just get a close-up of the handle. And it does say at the 0 down in there that it gives you a mark and says 0.001 inches so that there's no confusion. All right, Don.
Let's review the table controls. First of all, on the very right side, there's a wheel that has a handle that will snap out, and that's our longitudinal feed adjuster. That will move the table left and right, which is known as the x-axis. Now, there is also a set of table locks, okay, that Don said don't use those either. But if you did lock them down, they would prevent left and right motion of the table. And then you see the vise. So that's all there is to the table. A turning of the handle, one full rotation on the longitudinal feed will move things 200 thousandths of an inch, 0.2 inches in the x direction. Similarly, turning the cross feed or y-axis adjuster, one revolution will move things 200 thousandths as well. So there's the table controls. Next up is the machine controller.
I think we're just about done here. There's a unit up here. What's this thing called?
That's your controller. This machine's equipped with a CNC for X and Y.
Just stop you there, Don. CNC. I hear this a lot. I mean, what's it stand for, and then what's it mean?
Computer numerical control. It means I can run this part using a computer. It'll move it for me. I just program it.
So instead of me turning these handles, there's just like on the lathe, there's a power feed that can feed the table in the X direction. It can do the saddle in the Y direction. And unlikely for engineering students, it could move the Z, which would be moving the quill.
This machine is not equipped to have a power feed via the computer.
Oh, okay. It has a power feed via these handles here. It's a mechanical. Oh, okay. And there's only 3 settings.
Correct.
Whereas these power feeds in the other directions could have multiple settings.
Yeah, they call this a 2-axis CNC.
Okay, 2X. So generally, it's this table moving left to right and the saddle moving in and out. That's what's being controlled by the computer, which is through this unit. Now, Don, I see a big red button here. I guess one of the things we didn't talk about at the beginning is maybe what that red button is and even how to turn the power on to the machine. So how do you do that?
All right. To turn the basic power on to the machine, as earlier in the show, we couldn't turn the spindle on. Because this is a CNC, you have to have the main power on. And to turn the main power on, if Jason, you can swing around to the side here. You have this silver switch right here. In order to turn the power on to the machine, it's a matter of flicking the switch in an upward position.
Don, it says here, warning, do not shut off power until display reads, it is now safe to turn off your computer. That's probably like your computer shutdown procedure. You don't just turn the power off. You have to do a shutdown procedure on the monitor.
That's correct. This is a computer-based software. As you can see, as it's firing up, it's Windows-based. So we have to shut this down. It is a computer, and there's a process to do that, and we'll go over that when we go to shutdown.
Okay, so we've turned on the power. It said Windows. How do we just get it so it's just basic showing like as a DRO like on the lathe, or is that a long process?
No, that's a fairly easy process. You see this button here? This looks like a triangle. It says mode. If we hit mode, it comes up with a bunch of soft keys down here. And on these soft keys, we can say DRO. We have a bunch of menus here that we can use at this point. So if I want digital readout, which is what's represented with DRO, I put DRO, and now I'm able to turn on my spindle. I am able to set my X and Y, Z. You can see the travel in X. You can see the travel in Y. And you can see travel in Z.
Oh wow, that's like magic. Now, so the spindle can be turned on now, Don?
Yes, it can be.
Okay.
So
Okay. And this button here is what?
that is your e-stop, and you need to know where that is in case you get yourself in trouble.
So that's the emergency stop. You just push that in. It will stop. It'll stop the spindle. All right, it does stop the spindle, but notice there's a lot of momentum in that would still carry on. So even if you hit an e-stop, you could still get yourself cut.
That's correct. Keep your hands out of the window of the cutting edge.
All righty. Emergency stop has been activated. It says correct the fault and continue. How do we continue?
How do I correct the fault? You can see that there's arrows on this e-stop. I rotate, pull out. And hit return.
Okay, so he pulled that out, return. We hope that you're never going to have to hit an e-stop, but it's always good to know where that is. Now, the shutdown procedure, Don, once again, I don't just flip this over here. What do I do?
You go to on the left-hand side of the screen. You got an acronym that says SYS. Hit System. We're going to go to Shutdown, and it's going to ask you, do you want to shut off the main power switch? Yes. Hit yes. It goes through its shutdown procedure.
Are there any video games on here I can play?
No.
Okay. All right, it says it's now safe to turn it off. So the button on the side, can I have the honors? Okay. All right, so that's a shutdown procedure. All right, well, I think we've gone over the setup. You'll be quizzed on some of these parts and what they mean and what they do. So study up. Thanks.
We're going to get into the machine controller a lot in subsequent videos, but let's just talk about some of the more basic operations. First off, to be able to use the machine and turn on the spindle, you have to first engage the power switch into the up position on the right side of the controller. It's not shown here in this photo, but it was in the video. So you flip that up. Now, if you want to use the controller just as a simple DRO, or digital readout of your X, Y, and Z coordinates, you can hit the mode button, and then up on the screen will be a bunch of menus, and then you'll use one of the menu keys below the screen to make the proper selection. When you get yourself in, or if you get yourself into some trouble, you hit or just press this e-stop. This will stop the spindle from spinning. Remember, there's going to be momentum in that spindle, so it's going to continue to spin for a few seconds after you hit that. But the e-stop will also stop any motion of the table or the saddle. When you have solve the problem of why you put the e-stop in the first place, if you want to disengage it, you would turn it in the direction of the arrows and then pull it out. Then there'll be something on the screen to say, do you want to continue, and you'll hit return, and you'll be able to continue on. Lastly, when it's time to shut down, this is just like any other computer shutdown. You just don't do a hard power shutdown. You're going to do a software shutdown first. So that's going to be initiated by pressing the SYS button. I think that stands for system. Major system operations will come up on the screen when you hit this SYS, including do you want to shut down, and you would then go through some menu items to say yes, and then a message on the screen would say it's now safe to turn your machine off. So that's the machine controller. Next up, we're going to look at some questions. Hey, as promised, there's a few questions for you to answer to see if you've understood the important points of this video. Make sure you write these out and hand them in to your lab instructor. Number 1, draw a rough sketch of the head of the mill and label where the following controls are. Spindle on-off knob. This was the knob that actually had the 0, the 1, the 2 on it. The spindle brake, the speed control knob, and the high-low neutral knob. Now, you don't have to have a photorealistic sketch here. Just a rough shape showing approximately where the handles and knobs are for each of these items listed. Number 2, in what axis direction does the knee of the mill move? You've got 3 choices, X, Y, or Z. And along with that axis direction, say if it's left, right, up, down, in, or out. Repeat this question for the saddle. So which way does the saddle move and what axis direction is it? And then also finally do the same question a third time for the table of the mill. Number 3, where's the oiler located on the track milling machine? How and when should it be used? Number 4 says, what axis directions are controlled by the SMX controller of the track mill? And 5, list the steps for properly shutting down a track mill controller. You're going to see this cool machine in action in subsequent videos, so stay tuned and you'll be in great shape to use these machines to your advantage and in a safe way. See you next time.